So we want to find the derivative of a quotient of functions like this. If y equals f of x over g of x, we want to find dy dx. And we can't just say, well, this is the derivative of the top over the derivative of the bottom. It's not like a sum or a difference. What we need is we need a quotient rule. So let's see if we can find us a quotient rule. Okay, so dy dx, here we go. We're going to, so what we're going to do is we're going to take the limit. Let me give myself some room here. The limit as h goes to 0. And we'll do this. We'll do f of x plus h over g of x plus h minus f of x over g of x. All that over h. Yeah, there it is. Now that's the difference quotient. So that right there, that's the derivative. But we need to, we need to simplify it, see if we can come up with a formula. So what I'm going to do is I'm going to multiply through by g of x plus h. Here, here, and down here. Now when I multiply here by g of x plus h times g of x, when I do that here, the g of x plus h will cancel. Likewise, when I multiply here by g of x plus h, the g of x will cancel. And here's what I'm going to end up with. Here's what I'll end up with. Up top, right here, I'm going to get f of x plus h times g of x. Notice I just multiplied through by the denominators here. Minus, over here I've got f of x times g of x plus h. Okay. And then down here, of course, I've got everything, nothing canceled at all. So down here, I've got h times g of x plus h. Yeah, there we go. So I just kind of real quickly cleared the denominators here. It's just a standard multiplying through by the least common denominator. Now I have this. Now I want to do a little trick up here. I'm going to add and subtract f of x times g of x. So here's what I've got. I've got the limit as h goes to 0. I'm going to do a trick here. F of x plus h, g of x. But I'm going to add, right between these two terms, I'm going to add an f of x, g of x. And I can't just add that. I have to subtract it off or else I've changed things. So I don't want to change anything. I'm just doing this for my algebraic manipulation that's coming. So, minus f of x, g of x plus h. There. No worries. So, what I've done is I've just added 0 to the top. And that's nothing, right? So then I've got h, g of x plus h. Okay, no problem. Now, I want to do some regrouping. That's what I want to do. Now, notice, I think what I want to do is I want to group this term and this term together. Yeah, that's what I'm going to do. I'm going to group those two terms together. So let's see what we've got now. We've got the limit as h goes to 0 of f of x plus h, g of x, minus f of x, g of x. Okay, I group those two together, and then I just put everything else together over here. I've got plus f of x, g of x, minus f of x, g of x plus h. Okay, no worries there. Okay, and then down here, nothing has changed. Everything's just happening to the top. Okay, now I'm going to give each one of these its own limit. Notice I've got the same denominator. I'm just going to split up the fraction. That's all I'm going to do is just split up the fraction. Okay, so I've got the limit as h goes to 0. Now, So I'm taking this, f of x plus h, g of x, minus f of x, g of x. I'm going to put that all over this thing. Like that. See? So I took this first part, put it over this. Now I'm going to take the second part. Okay? All of this. See? Just put that together all over the bottom. The bottom kind of looks like a mess. There's a lot to it down there. Okay, there we have it. So now this and this are the same. These two are the same. I've just rearranged things there. Now I want to take a look here. Notice this g of x. It has no h with it. I think what I'm going to do is I think I'm just going to factor out the g of x, and okay, so let me factor out that g of x. Let's see what happens here. Now it doesn't have any h with it, so I'm not going to put the limit as h goes to 0. I'm just going to write it this way. I'm going to write the limit as h goes to 0 of f of x plus h minus f of x all over h g of x plus h. Now, over here, I think what I'm going to do is factor out an f of x. See? I've got an f of x. So let me do that. F of x. And I'm doing this. There's other things I'm going to do, but I'm doing it a step at a time. Okay? Whoops, this is g of x. I factored out the f of x. Okay? G of x minus g of x plus h. All over this thing. There we go. Okay. Now, I want to take a look here. If you look at this first part here, this is almost the derivative of f. It's f of x plus h minus f of x over not just h, but all of this stuff. I hate that. I hate that all that stuff is there. So I think what I'm going to do is I'm going to move this to the outside and put a limit. So I'm going to make some changes here. I'm going to keep the g of I'm going to put everything in a limit. Okay? Since this part does have an h with it, I've got now the limit of g of x. This is the limit as h goes to 0 over g of x plus h. Yeah. So I put the limit there for the sake of this g of x plus h. But then we have the limit as h goes to 0 of f of x plus h minus f of x over h. Now notice, everything's the same. I just took part of this bottom and put it on the outside and gave it its own limit. Now you might be tempted to cancel off this g of x, but I'm not going to do that because I'm looking to develop a formula. I'm not looking to simplify this. I'm looking to develop a formula, so I'm going to leave that alone for now. Now, if you look over here, this is almost like g prime of x. I've got g of x minus g of x plus h all over h. Well, let me just switch the order there and put a negative on the outside. And also, let me factor out this bottom, g of x plus h. So I'm going to have this. I'm going to have the limit as h goes to 0 of f of x over g of x plus h. And then I've still got the derivative there, or the limit. Yeah, here we go, like that. See, a lot went on there. First of all, I factored out this negative and I changed the order. So this plus became a negative. And then I took this stuff down here, g of x plus h, put it on the outside, and put a limit in front of all that on the outside. Okay, so a lot went on there. But now look what I have now. For this first bit here, this is just going, look, this is f prime. This down here, if you let h go to 0, is going to be g of x squared. So look what we have now. For this first part, we have g of x times f prime of x all over g of x squared minus, and let's look over here, we've got f of x times g prime of x over g of x squared. Dig this. Dig what's going on here. Now, these are the same denominators. So here's what I have now. If I put all this together, I've got f prime of x times g of x minus g prime of x f of x all over g of x squared. And this is the quotient rule. Notice, we've got the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. So let's see how this would work. So let's suppose we have 2x plus 3 over 5x plus 2. Okay? And we want to look at the derivative. Okay? Here goes the derivative. Well, we take the derivative of the top times the bottom minus the derivative of the bottom times the top. See that? Derivative of the top times the bottom minus the derivative of the bottom, see, times the top, all over the bottom squared. And there's our derivative using the quotient rule. Now, I would simplify a little bit, multiply out the top. Now, don't ever multiply out the bottom. That's rarely going to help you. But you do want to multiply out the top and add like terms. So I got 10x plus 4 minus 10x. Watch yourself now. This minus distributes. Okay, like that. And then we just add like terms, and let's see what we have now. We have 10x minus 10x. Okay, that's 0. 4 minus 15, that's negative 11 over 5x plus 2 squared. And there's your derivative by using the quotient rule. So the quotient rule. So if you have the quotient rule here, then what we're saying is that you can find the derivative of that by saying the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. And that is the quotient rule.